So, welcome to our lecture, uh, energy management. And energy management, we are going to discuss the demand side management. So, till that, we have learned that what is the importance of energy management, power factor management, and how to improve the power factor. What are the technical and what are the financial advantage of power factor management? Because of uh, kVAH billing, it become very important to maintain the power factor near to unity. It should not go to the leading side also, or it should not be a lagging side less than 0.95 power factor, leading or lagging. Okay, so today we will discuss the demand side management. So, what is the demand side management? The demand side management is the modification of consumer demand of electricity through various methods such as financial incentive and consumer education. So, we do not want to curtail the load. We do not want to switch off the electricity supply to the consumer. Only we want to educate the consumer such that they should modify their electrical demand or electrical load. So what is meaning of education? The education is meaning is to aware the people what is the advantage of energy management, what is the advantage of energy conservation, energy audit, and how to maintain the load nearly constant throughout 24 hours. If someone is consuming the energy during some particular period and rest of the time the load is very small, or say it is zero, under such condition the load factor is very small, and hence the relative, hence we can say that the energy cost will be very high, is the one thing. Second thing is that in some particular time of period, the load on the generating system or the load on the generating plant is very high, and rest of the time the power plant is running at a light load condition. So it is not a economical way to run the power plant. One thing. Second thing is that, next thing is that, if you are running in such a way power plant that is sometime the load is very high and rest of the time is very low, under such condition we are not utilizing the electrical infrastructure. So it is advisable to the consumer, it is say it is the need to educate the consumer that they should maintain the load as long as constant as possible throughout 24 hours day. No doubt it is possible for the industry. So we will teach the people, we teach the industries that they should avoid the maximum load occurrence due to during peak period, whereas they have to shift some of the less priority load, some of the less priority feeders, or some they have to maintain some stock pillars in such a way that they are going to run their plant 24 hours, 24 hours, and so as to maintain the load curve is as flat as possible. Second, this is going to obtain with the help of some financial incentive. No doubt nobody is ready to maintain the load, nobody is ready to run their plant in the night time, or why to run their pumping load and say chilling plant in the night time. It is possible only when they will get the benefit of somewhere benefit in the finance, somewhere benefit in the electric bill. So we have to give some financial incentive those are consuming the energy in the night time. So in this contest, the electricity utility industries has a TOD tariff, time of day tariff. In time of day tariff, the energy rate is different for the different period of time in the day, in the one day. Say in the night time from 6 p.m. to morning 6 a.m., the rate is decreases by 1 rupees 50 paisa in the basic rate of electricity. Say the basic rate is 5 rupees, it is get detected 1 rupees 50 paisa. So the rate of electricity during 10 p.m. to morning 6 a.m., it is only 3 rupees 50 paisa. At the same time, if someone is consuming the energy during the peak load, they have to pay more money. So there is some penalty, or there is some additional rate has been added in the basic rate of electricity. So now your basic rate is 5 rupees per unit. Now it is added by 1 rupees 10 paisa during evening time, that is a peak hours. It is 6 p.m. to 10 p.m. Evening 6 to 10 p.m. So by using some financial incentive, financial additional burden over the consumer demand, and by educating the consumer, definitely we can modify the electrical load of the consumer. If you are able to modify the electrical load of the consumer, definitely it will gives the demand side management. And what is the objective of demand side management? Is to reduce the gap between generation and demand. We will observe that day by day the electricity demand is go on increasing. Whatever the rate of increase of the whatever the rate of increase in demand of electricity, we are not able to increase the capacity of plant, and hence the gap between generation and demand is go on increasing. So, the best method or the best tool which is available to bring down the gap between generation demand is demand side management or energy conservation. No doubt, we have to increase the generating capacity, but we can say postpone the installation of new power plant, because the say the investment in the power plant installation is very huge. Again, it is related to the social cause of the country, because nobody is ready to give the land. It is the environmental effect. You have to construct some dam. In the dam construction, you have to increase the catchment area, water catchment area, and hence you have to reach settled the people those are living nearby to the that proposed construction of the dam area. Okay, so these are the points are has to be considered in the demand side management. Now, usually the goal of demand side management is to encourage the consumer to use less energy during peak hours, or to move the time of energy used to the off peak period hours like night hours. So our objective or our goal is to encourage the consumer or educate the consumer that the consumer should consume less energy during peak hours. What is our peak hours? Peak hours is in the daytime 9 a.m. to 12 p.m. It is a morning time. This is the time. Second, why it is? Because every type of work is started from the morning. Okay, so the load offices, say department, government departments, offices, college, institutes has been started in the morning time. The load get increases. At the same time, the companies which is going to run only in the daytime, the load also get added. So during that time also, one of the peak hours is 9 a.m. morning 9 a.m. To the 12 noon. Okay, and second peak, which is a higher peak, is there. It is 6 p.m. to 10 p.m. So this is during that time all type of residential consumer is on, commercial buildings are on, transportation is on, so everything is on during that time. Okay, in addition to the industries. So therefore, these two is the peak period in 24 hours. So we are educating the consumer in such a way that they should reduce the consumption during that time. Okay, if they are able to reduce the consumption, or if they are able to shift that load into the night time, definitely it will increase, it will maintain the power, it will maintain the load curve as flat as possible, one thing. Second, it reduces the relative generation cost of the plant, and hence we will avoid the occurrence of maximum demand, and we can avoid or we can postpone the generation of new power plant. So this is the objective of demand side management. Now, need of DSM, saving of 1 unit of electricity at the consumer end, avoid nearly 2.5 time capacity of capacity addition. What it means? we come to know that in the very basic or first or second lecture of energy conservation and management, we have drawn one flow chart, and it flow chart says that what are the different losses take place from coal handling plant to the power generation facilities. It may be the conversion facilities, that is, it may be a power plant, it may be a refinery. In case of a refinery, we are taking the crude oil or raw oil are there, and it is get refined into the refineries. Some there are losses. Then there is a transmission in electricity with the help of transmission lines and conductors are there. Definitely there are some losses. In case of refinery, the transmission is carried out with the help of pipelines, with the help of railways, with the help of trucks, isn't it? So definitely there is some losses are there, and it is going to reach at the doorstep of the consumer, especially for the electricity. So there are number of losses are there, transmission distribution losses are there. Again, it is consist of technical as well as the commercial losses. Second, whatever the device, if you are using the pumping, the pump has some different efficiency, motor has different efficiency, the total pump set efficiency is smaller, and finally it is get converted into the useful form. So there is a continuous losses from generating unit to the consumer end. So at the consumer end, if you are able to conserve the 1 unit of electricity, it will avoid nearly 2.5 time capacity in addition. The meaning is that if you want 1 megawatt of energy at your doorstep, so at least 2.5 megawatt capacity has to be installed in the generating plant, isn't it? If collectively we are conserving the 1 megawatt power, the meaning is that we have virtually enhanced the capacity of power plant by 2 megawatt or 2.5 megawatt. So by this way, if we are doing the energy conservation, if we are doing the demand side management, if we are utilizing the electrical energy very effectively, the meaning is that we are enhancing the capacity of power plant, and hence we are able to avoid the additional capacity, or we can postpone the installation of power plant for 2 3 years. During that time, the new technologies will make them, and during that time we can collect some revenue to install a new power plant. So I think it is a very good example to understand what is the need of energy conservation, demand side management, and energy audit. Okay, so what is the estimated cost is there? It is found that it is roughly, if you want to install the 1 megawatt capacity addition thermal plant, if you want to install 1 megawatt capacity of thermal plant, nearly 6 crores for the installation, and other 3 crores for the transmission and distribution. Say this is the some rough idea for the 1 megawatt. Say if you want to install 600 megawatt capacity, so it is a 600 crores is needed for the installation of power plant, and to evacuate the power or to transmit the power to the load center, you have to add some transmission capacity, because the existing transmission capacity is not adequate, it's not sufficient, because you are increasing the generation, so you have to increase the generating capacity of transmission line. So by adding one more transmission line, it required some land, it required some infrastructure, conductors and towers are there. So 3 crores, so nearly 9 crores are needed for 1 megawatt power additional generation. So if you want to install 100 megawatt, so there is a 900 crores rupees are needed to install the 100 megawatt power plant. So therefore, it is very advantage to do the energy conservation and energy management. If you are able to do the energy management, if you are conducting the energy management, or using a very proper judicious use of electrical energy, definitely we can avoid this much investment in the installation. Okay. Similarly, if you want to install the thermal hydropower plant, again the cost is very high, because it include the cost of dam construction. So dam construction needed a very huge amount, in addition to the power plant and transmission. So power plant installation as it is, their transmission evacuation of power facilities remain as it is, means that cost is there, but additional cost is needed for the construction of dam, acquisition of land, resettlement of the people those are living nearby to that damp area. So this much cost also get added in the additional power plant capacity in the hydro section. Okay. Now, then who demands electricity? So we will have some two questions are there, and from these two questions there is a collective say responsibility of the consumer as well as the utility to do the demand side management. Okay, so only one cannot do the demand side management effectively. So who demand the electricity? Definitely the consumer. There are different type of consumer: industrial, commercial, corporations, and there are many. So as already we have discussed this point, there are different type of consumers are there, so all consumer need the electricity. Then who will manage the demand for the electricity by the consumer? The service provider, with equal participation from the consumer. So who is responsible to do the energy management or demand side management? Definitely the service provider, those providing the service. In Maharashtra there is a MSDCL, there is a some Reliance Power, it may be a, some India Bulls, they are going to generate the power. Then Best is there. So all this one are responsible to do the demand side management in participation of the all type of consumer. So all type of consumers should do the participation from its end. Either if it is a residential consumer, the residential consumers should think that if my consumption in the range of 110 unit, so what would be the ethical way to reduce my consumption in the range of 100 kilowatt, because sorry 100 unit, because more than 100 unit I have to pay more cost. So again here it become a financial incentive and financial burden. When there is a financial incentive, financial burden is there, then it is possible to the consumer to do the energy management. Similarly, if it is an industrial load, industrial consumer, the consumer will try to reduce its maximum demand by improving the power factor, by shifting some of the load to the off peak period, by shifting some less priority load in the night time. He can do some energy stock pillars, like he will pump the water in the night time, he will maintain the lower temperature in the night time for the say warehouse, and some such type of brew house are there, isn't it? So the consumer also participate in the demand side management, and he will participate, the consumer will participate only when he will get the benefit in finance. He will get whenever he will get the benefit in its electricity bill, in his electricity bill. So when the consumer gets some electricity bill reduction, then it is possible to do the demand side management. So demand side management is not only the technical way, not only by educating the people, we have to give some incentive, we have to impose some sort of penalty, then it is possible to do the demand side management. So therefore the demand side management has to be performed by service provider as well as the uh, consumer. Now see, this is one particular demand curve is there. It is the some system in megawatt, load in megawatt, and here it is the say hours, 24 hours is there. It is found that the load is smaller during that time. It will become somewhat flat, and during that time the load become very high. So its peak demand is nearly say it is 44 or 43 thousand 4300 megawatt is there, and it is going to occur only for 1 2 3 4 5 hours, or it is say 4 hours is there, only the demand is going to occur for 4 hours, whereas the load is constant. So now think toward the generation side. If demand is increases only 3 to 4 hours, and whereas the rest of the time the generator will remain under load condition. For example, they have installed the power plant of 404.5 megawatt is there.